We make choices all the time based on cost and value. But what if I told you that a ton of these decisions, think choosing a phone plan or even just hailing a cab, they all follow the exact same mathematical rule? Well, today we're going to uncover that hidden code. It's a simple structure for constant change that, I promise, once you see it, you're going to start seeing it everywhere. So let's just dive right in with a super practical choice that, honestly, a lot of us have to make: picking a health insurance plan. Now, on the surface, this seems pretty straightforward, right? But as you're about to see, the best deal, well, it isn't always the one you think. Okay, so here are our two options. You've got Plan A, which looks pretty tempting with that low $100 monthly fee, but it's going to cost you $25 every time you see a doctor. Then there's Plan B. Yeah, the monthly fee is steeper at $160, but each visit is cheaper, only $15. So which one's the better deal? Well, it really all depends on how often you think you'll go, right? But the real question is, how do we find that exact point where Plan B suddenly becomes the smarter choice? Well, the key here isn't to just, guess or run a bunch of different scenarios in your head. No, the answer lies in this really powerful mathematical tool that's specifically designed for any situation that has a fixed starting point and a constant rate of change. This thing lets us model these offers with total clarity and pinpoint the exact moment the better deal flips from one plan to the other. So this framework, this constant change code I've been talking about, in the math world, it's called an affine function. And it's basically the secret recipe for modeling any scenario that combines a flat fee with a variable cost that just grows at a steady, predictable rate. And believe it or not, this simple formula right here, f of x equals a times x plus b, that's the entire blueprint. That's all it is. So let's break this down because it's actually super simple. F of x, that's just our total cost. It's the final number we're trying to figure out. X is our variable, right? In this case, it's the number of doctor's visits. But the real magic, the secret sauce, is in A and B. These two little letters represent the two core parts of our problem: the variable cost and the fixed cost. And if you understand them, you've pretty much unlocked this whole system. Okay, so let's really decode those two crucial parts of the formula. Yeah, in math class, you'd call them coefficients, but you can just think of them as the two main levers that control the final cost: the number A and the number B. So let's start with B. B is your fixed cost, your initial value. You can think of it as the starting point before anything else happens. In our health plan example, it's that fixed monthly fee, the $100 or the $160 you have to pay, even if you don't see a doctor all month. Simple enough, right? Then you have A. This is your rate of change. This is the cost that varies with each unit. For the health plan, this is that $25 or $15 cost that gets multiplied by X, our number of consultations. And like I said, this isn't just for health plans. This structure is literally everywhere. It's the hidden engine behind so many pricing models we deal with every single day. Think about a taxi fare. You've got the flat fee just for getting in, that's your B, plus a cost for every kilometer, that's your A. Or your phone bill. It's the monthly fee, B, plus what you pay per gigabyte of data, A. Even big economic ideas like product demand follow this exact same logic. Seriously, once you see this pattern, you just can't unsee it. Okay, but here's where this whole concept gets really, really powerful. When we take an affine function and we plot it on a graph, it doesn't make some crazy random curve. Nope, it always creates a perfectly straight line. And the story that line tells, well, it reveals everything we need to know. That's because the graph of an affine function is always a straight line. Every single point on this line is a possible outcome, a specific number of visits, and exactly what it'll cost you. And the fact that it's a straight line is so important because it means the change is constant and totally predictable. And remember our friends A and B? Well, they're the only two things that control exactly what this line looks like. It's an amazing visual tool. So that A value, the rate of change, that's what controls the slope of the line. How steep is it? If A is positive, like with our health plans, the line goes up. It makes sense, right? More visits, more cost. If A is negative, the line goes down. Think about product demand. Sometimes to sell more stuff, you have to lower the price. And if A is 0, well, the line is just flat. The cost never changes no matter what. And what about B? Well, B is even simpler. It's just the starting point. It's where the line crosses that vertical y-axis. It's the cost you pay when X is 0. Basically, it's your flat fee before any of the per-use charges kick in. Okay, so that's the starting point. But sometimes we need to ask the opposite question, right? At what point does the function equal 0? We're not looking for the start, We're looking for the break-even point, or where it all zeroes out. So how do we find that 0 point? Well, mathematicians call this finding the zero or the root of the function. And the process is actually super straightforward. You just start with your function, ax+b, then you set the whole thing equal to 0. From there, it's just a little bit of simple algebra to solve for x. And what you find, visually, is the exact spot where your line crosses the horizontal x-axis.
All right, we've got all the tools we need now. Let's go back to our original problem and solve this thing once and for all.
So, first things first, let's model the health plans. We just translate each one into its own function. For plan A, the function is a of x equals 25x plus 100. And for plan B, it's b of x equals 15x plus 160. Okay, now let's put these functions to the test. Let's say you only go to the doctor 3 times. As you can see, plan A is the clear winner. It's cheaper. But what happens if you need to go more often? At 6 visits, look at that, they're exactly the same cost. And if you go 9 times, suddenly plan B is the cheaper option. See how the tables turn? That number, 6, is the break-even point. At exactly 6 consultations, something really important happens. The cost is identical. It's our equilibrium. If you were to draw these two functions as lines on a graph, this is the exact spot where those two lines would cross. And there it is, the final verdict. So if you think you're going to have fewer than 6 consultations, plan A is absolutely the more economical choice. But if you think you'll have more than 6, then plan B is without a doubt the better deal. The math makes the decision crystal clear. And remember, this way of thinking goes way beyond just your personal finances. This same logic is used for really complex economic principles. For example, the law of demand is often described as a decreasing affine function. It's just a straight line, showing that as price goes down, demand goes up. Same idea. So, what other patterns in your world follow this simple logic of a straight line? The affine function, it turns out, is way more than just a formula from a math book. It's like a lens for seeing the hidden, simple order in the world around us. So now that you know the code, the only question is, where else you're going to see it?